Okay, so let's start today's lecture. Okay, so now we have been talking about non-homogeneous equations from last lecture. Okay, so this type of equations have the form x prime is equal to a of x plus the g of t. Okay, so that's what we have starting from last time, right? So now we've been talking about the method of variation. Okay, so variation of parameters. Uh, so we've been talking about the method of variation of parameters. So in that method, let me remind you the formula there. Okay, so the formula there is to consider the linear system. So I mean homogeneous system x c prime is equal to AFC, and then as we got the so-called fundamental matrix. Okay, so we got the fundamental matrix, the psi of t. Okay, so psi of t, and then the general solution. Okay, so the general solution. Okay, so general solution is going to look like x of t is equal to psi t multiplied by c, right? So that's what's the system for solution for the corresponding linear system, and then the nonlinear. Okay, sorry. So the non-homogeneous part is going to give you like psi t of the integral of psi inverse of s, right? So multiplied by g of s, this integration is up to level t. Okay, so that was what we discussed in last lecture about the variation of parameters, right? So in particular, you have to kind of calculate the cosine inverse and then integrate the whole in matrix vector multiplication and then multiplied by cosine of t. So that's kind of a nice formula. Okay, so a nice formula for the non-homogeneous system. Okay, so now today I'm going to talk about another method is the method of undetermined coefficients. Okay, so how do we use method of undetermined coefficients? Let's say, okay, so how do we use the method of undetermined coefficients to calculate this non-homogeneous system? Okay, so let's say non-homogeneous system, right? So I want to use the method of undetermined coefficients to calculate the non-homogeneous system. Okay, so to that end, we're going to look at this example. Okay, so we're going to look at an example from our textbook. Okay, so we're going to look at an example from our textbook. Okay, so this is an example that we're going to take from our textbook. Okay, so that's the example. Okay, so the example is to find a general solution of this system. Okay, so this is the right hand side. Okay, so basically the vector g of t is written as t multiplied by g. Okay, so that's actually g is a fixed vector. So that's like -9 times t, 0 and -18 times t. So that's t multiplied by g. Okay, so then we're going to kind of calculate this solution to this problem by method of undetermined coefficients. So how are we going to do that? Well, remember the method of undetermined coefficients says that if the right-hand side, okay, so here is the right-hand side is g of t is a polynomial, right? So this here, you're not going to have like one polynomial, but you're going to have a polynomial vector. Okay, so then we're going to call it polynomial. Okay, so polynomial vector, because it's a vector that consists of polynomials, right? So, but then it means that you should choose something similar to that, right? So you should choose something similar to that. So that means first of all, you have to find a general solution, right? So once you find a general solution, you're going to find a particular solution. And once you have general solution and a particular solution, you have to kind of try this particular solution and find the particular solution. So that means we have to kind of first look at, okay, so let's say we first, okay, so we first look at the complementary equation. Okay, so right? So you should first look at the complementary equation. So that means that xc prime is equal to a of x. That's the complementary equation. How do you solve the complementary equation? Well, it means that you have to calculate the eigenvalues and eigenvectors, right? So the eigenvalues, eigenvectors here is for 3 by 3 matrix. Okay, so that's not so easy, but you can still calculate it. So basically, you calculate the determinant of A minus R times I. So that means you're going to have the determinant of, so here is the 1 minus the R, and then the minus 2 and 2. Okay, so minus 2 and 1 minus the R, and 2 and 2 and 2 and 1 minus the R. So that's A minus Ri. Now you want to calculate determinant. So you have to calculate determinant of a 3 by 3 matrix. Okay, so you calculate determinant of a 3 by 3 matrix. Okay, so it was calculated somewhere in this previous example. Okay, so it was calculated in a previous example of this textbook. Okay, so of this textbook, so it should be somewhere here. Okay, so that's in an example. So we calculate this determinant. Okay, so this is the same matrix A. We want to calculate determinant so that you just have to kind of do a little bit of your algebra. So that means you have to multiply this 3. So 1 minus R to the power of 3. And then you're going to multiply this 2 by this, right? So with positive signs, so that's minus the 8, right? So, and then the minus the 8 again, and then you're going to go reverse direction. So minus 4 times 1 minus R. Okay, so, and then it's going to be minus 4 times 1 minus R again, and then it's going to be minus 4 times 1 minus R. So that's going to be this factor. So now you can see, okay, so you can see that this is nothing but, okay, so it's nothing but 1 minus R cubic minus the 16 minus the 12 times 1 minus R. Okay, so that's going to be this scenario. Now you have to kind of do factorization. Okay, so you have to do a factorization. So that means that here I'm going to write this like 1. Okay, so minus okay, so 1 minus the 3 times R, right? So, and plus 3 times R squared minus the R cubic. Okay, so that's going to be this situation. Minus 16 minus 12 plus 12 times R. Okay, so that's going to kind of give you here you are going to have, so minus R cubic, right? So for the quadratic term, we have 3R squared. Okay, 3R squared. And then you are going to have, okay, so minus, so plus 9 times R, right? So 12 minus 3, right? So, and then it's the 28, right? 28 plus 1, so minus the 27. So you're going to have something like this. Now here it means that this is R squared. You can factor minus R squared out. It's R minus 3, and then plus 9 times R minus 3. So that's 9 minus R squared multiplied by R minus 3. So that you're going to have 3 plus R multiplied by 3 minus R, right? So 3 minus R multiplied by R minus 3. So that's going to be like, indeed, you're going to have like minus times R plus 3 multiplied by R minus 3 squared. So that's going to be determinant. If you set the determinant equal to 0, you're going to see that the first eigenvalue is minus 3, the second and the third eigenvalue are equal to 3. So that's going to be the scenario. Is that good for everybody? Okay, so that's the same thing as what we calculated here. Okay, so now you can see that we are going to calculate. Okay, so we're going to calculate the eigenvectors, right? So, but the eigenvectors have problems here. One is eigenvector is corresponding to the eigenvalue minus 3. The other two eigenvectors are corresponding to the same eigenvalue 3. Okay, so that means, let's say we start from the eigenvector, right? So eigenvector of eigenvalue. Okay, so eigenvalue. Okay, so R1 is equal to minus 3, right? So minus 3 is going to be the first eigenvalue. you want to find the eigenvector. So eigenvector, it means that you are going to just solve this linear system of equations. So 1, minus 2, and 2, right? So, and then minus 2, 1, and 2. And then it's 2, 2, and 1 multiplied by the eigenvalue. Okay, vector x1, x2, x3 is equal to minus 3 times x1, x2, x3. So that's going to help you to find an eigenvector. So this eigenvector system equation is x1 minus 2 times x2 plus 2 times x3 minus 3 of x1 minus 2 times x1 plus x2 plus 2 times x3 is equal to minus 3 of x2, and 2 times x1 plus 2 times x2 plus x3 is minus 3 of x3. Okay, so that's going to be a 3 by 3 system of linear equations from which you should be able to solve for an eigenvector. So in order to do this, you can see that we have to kind of reduce this equation a little bit. So the first equation is going to tell you that 2 times x1, right? So because, so 3x1 moved here is a 3, so plus 1. So that's a 4 times x1 minus 2 times x2 plus 2 times x3 is equal to 0. And for this equation, you're going to have like minus 2 times x1 plus the 4 times the x2 plus the 2 times the x3 is equal to 0. And this equation is going to give you like 2 times x1 plus 2 times x2 plus 4 times x3 is going to be equal to 0. Is that good, family? Okay, so that's going to be these 3 equations. Now, from these 3 equations, we should be able to solve. Okay, so we should be able to solve for the linear system of equations. Okay, so here is a 4 minus 2 and 2, and minus 2, 4, and 2, right? So minus 2, 4, and 2, and you have a 2, 2, and 4. So how do we find a vector, right? So how do we find a reasonable vector that satisfies these 2 equations, right? So that's going to be like a nice thing, right? So you can see that if you let this to be the first and second and third equation, then there's a kind of a redundancy here because the equation 3, right? So minus the equation 1. Okay, so equation 3 minus the equation 1, you are going to just have the equation 2. Okay, so which means that this is not a necessary equation, but you just need these 2 equations, right? So thus we are going to see that this equation is just to give you like 2 times x1 minus the x2 plus the x3 is equal to 0, and x1 plus the x2 plus 2 times the x3 is going to be 0. Is a good family? Okay, so that's going to be the scenario. Once you have that, you can see that the eigenvector, okay, so eigenvector can be taken by, so these are 2 independent equations from which if you set, okay, so let's say if you set, okay, so let's say you set x3 is to be 1, then you're going to have like 2x1 minus the x2 minus 1, and x1 plus the x2 is equal to minus 2. Okay, so that's going to give us, okay, so you add these 2 equations, so the x1 is going to be minus 1, and x2 is going to be then equal to like minus 1. So we're going to have minus 1, and 1. That's the first eigenvector. The good family. Okay, so that's the first eigenvector that you can find. Now we want to find the other 2 eigenvectors. Okay, so we want to find the other 2 eigenvectors, but then you can see that the eigenvalues, right? So the eigenvalues doesn't have 3 different eigenvalues. The other 2 eigenvalues are the same. So you must find 2 vectors corresponding to them. Okay, so that's kind of we're going to find eigenvectors. Okay, so eigenvectors of the eigenvalue. Okay, so eigenvalue R2 is equal to R3 is equal to 3, right? So that's the second and third eigenvalue, right? So in order to do this, you have to kind of work again with this matrix. So that means it's 1 minus 2 and 2, right? So, and then it's minus 2, okay, so minus 2, 1 and 2, and then it is going to be 2, 2 and 1, right? So 2, 2 and 1 multiplied by the vector x1, x2 and x3, that's going to be equal to 3 times x1, x2 and x3, right? So that's going to be like what you would like to have here, okay? So what you would like to have here. So therefore, this is going to give you a system of linear equations. X1 minus 2 times x2 plus 2 times x3 is 3 times x1. Okay, so minus 2 of x1 plus the x2 plus the 2 times x3 is 3 times x2. 2 times x1 plus 2 times x2 plus the x3 is 3 times the x3. So you're going to have this system of equations. Now we're going to kind of do a little bit of the algebra here. Okay, so you can see that the first equation is like minus 2 of x1 minus 2 of x2 plus the 2 of x3 is going to be 0. Now the second equation is going to tell you minus 2 of x1 minus 2 of x2 plus 2 of x3 is equal to 0. So that's the same thing as the first equation. And the third equation is like 2x1 plus the 2x2 minus the 2x3 is equal to 0. This is nothing but minus 1 multiplied by the first two equations. So either this one and this one or this one, they are neither this one, they are not necessary. They're both kind of redundant equations. We just need this equation, right? So we just need this relation. So this relation is simply, okay, so it's simply saying that x3 is equal to x1 plus the x2. So we want to find two eigenvectors. So that means x can be equal to, okay, so x1 plus x2 is x3. So it can be like, okay, so 1, let's say minus 1 and 0, right? So that's like that. And then the next vector, okay, so the next vector, okay, so can be like here 1, 0 and 1. Okay, so for example 1, 0 and 1 also satisfies this. That's good for everybody. Okay, so let's make us this is the, let's say the second eigenvector. Okay, so let me say u and v. Okay, so u and v, okay, so are linearly independent, right? So linearly, okay, so here let me do the following thing. Okay, so let me set this vector to be x1. That's the first vector. So that means ax1 is equal to r1 of x1. Okay, and I'm going to set these two eigenvectors are x2 and x3. Okay, so let's say this is x2, this is x3 are linearly independent. Okay, so you can check that these are linearly independent vectors such that ax2 is equal to r2 of x2 and ax3 is equal to r3 of x. So you have really the three eigenvectors. So that means the complementary solution. Okay, so right, so the complementary solution is actually found. It is found to be x of t is c1 e to the power of the first eigenvalue, right? So the first eigenvalue, if you remember, it was minus 3. So minus 3 of the t multiplied by the first eigenvector. The eigenvector is minus 1, and 1, right? So plus the c2 e to the power of 3t multiplied by 1 minus 1 and 0 plus c3 e to the power 3t multiplied by 1, 0, and 1. So that's going to be the complementary solution. Is that good for everybody? Okay, so that's going to be the complementary solution, and that kind of finishes, right? So finishes the complementary solution part, right? So and therefore we just need to find a general solution, a particular solution. So that means we want to find, okay, so a particular solution, right? So particular solution to the equation x prime of t is equal to ax of t plus t times the g. So we want to find a particular solution of this equation. So how do you find a particular solution of this equation? Well, here we're going to use, okay, so method of undetermined coefficients. Okay, so method of undetermined coefficients. So that means you first write this equation as ax prime is equal to ax, plus g of t, where the g of t, as I said, is a polynomial. So here, how do we understand this polynomial? Well, we're going to understand this polynomial as tg. So that's kind of a vector coefficient polynomial. So imagine that you have a polynomial like g multiplied by t, where g is a constant, then this is just the first order polynomial. Here, what happens here is that situation a little bit changed, namely the coefficient of the polynomial is replaced by the vector. Remember, the vector g is going to be equal, right? So as we discussed here, is minus 9, 0, and minus 18. Okay, so let's say minus 9, 0, and minus 18. So that's going to be the vector g. So you're actually trying, I would say, a vector valued, right? Vector valued polynomial. So therefore, according to method of undetermined coefficients, we're going to try a particular solution that's also a polynomial. Is that good for everybody, right? So how do we have a general polynomial? Well, the general polynomial should look like a plus t times b. It's the same thing as like a plus b times t, which is a first order polynomial. Here, it's replaced by vectors. Is that good for everybody? Okay, the coefficients are replaced by vectors. So once you have these vectors, you're going to try like x prime of t, and this situation is very much the same as constant coefficient polynomials. X prime of t is equal to b, right? So that's going to be the vector. So therefore, you can see that this is equal to a times the x of t is a plus t times b, and then plus t times the g. Is that good for everybody? So that means, so finally, right? So finally, you're going to reach the first following equation, which says that a times the a minus the b, right? So plus the t times the a times the b plus the g is going to be equal to 0. Is that good for everybody? Okay, so you have these two equations. And what does it mean? Well, this is again a vector valued polynomial equation. If a polynomial equation is 0, it means that, okay, so here's a 0 vector. If the polynomial equation is 0, it means that every coefficient is 0. So that you're going to have a multiplied by a is equal to b, and a multiplied by b is equal to minus the g. Is that good, family? Okay, so that's going to kind of give you this vectors, unknown vectors, a and b, by solving this two linear system of equations. So that means you have to first solve. Okay, so first solve. Okay, so first solve a multiplied by b is equal to minus the g. So I want to solve this equation. So what does this equation tell you? Well, A is this matrix, right? So that means you're going to have 1, minus 2, and 2, right? So, and then you're going to have minus 2, 1, and 2, minus 2, 1, and 2. You're going to have 2, 2, and 1. Okay, so 2, 2, and 1 multiplied by the vector B. Vector B is B1, B2, and B3 is equal to minus the G, right? So minus the G is 9, 0, and 18, right? So that's going to be the vector. So that you're going to have that system, another system of linear equations, B1 minus 2 times B2 plus 2 times B3 is equal to 9, minus the B1 plus the B2 plus the 2 times the B3 is equal to 0, and 2 times the B1 plus 2 times the B2 plus the B3 is equal to 18. So you can see that okay, so let's okay, so you can see that we can kind of try to solve such a system, right? So we can try to solve such a system, right? So let's just okay, so we can try to solve such a system, right? So that you can have to solve for such a system. So that means you can kind of find these vectors, right? So you can find these vectors, right? So let's see. Okay, so a plus t times the b. Okay, so a plus t times the b, right? So that means okay, so that means I can find these vectors, right? So I can find these vectors. So that means, let's see, first, let's check that it is correct. Okay, so is 1 minus 2 and 2, minus 2, 1 and 2, and 2, 2 and 1. Okay, so that's going to be the equation. Now, once you have this equation, okay, so once you have this equation, you can see that by first and the second equation, we can cancel the B3, right? So you cancel the B3. So that means that 3 times B1 minus the 3 times the B2 is equal to 9, which means that B1 minus the B2 is equal to 3. So that's going to be the first two equations. Now, from the first and the third equation, you can kind of, we can cancel the B3 again. So in order to cancel the B3, you have to multiply this equation into 4 times B1 plus 4 times B2 plus 2 times the B3 is equal to 18 multiplied by 2. Okay, so 36, right? So therefore, you subtract this equation from this. So 3 times B1 plus 6 times the B2 is equal to like 27. So that means B1 plus 2 times the B2 is equal to 9. So once you have both equations, it means that you calculated B1 and B2. Okay, so the B1 is so B2. Let's say B2 is you have 2, right? So and then the B1 is going to be equal to let's say okay, so the B1 is going to be equal to 5. Okay, so that's sorry. So the B1 is just one moment. Okay, so the B1 can be okay. So right. So the B2 is just one moment. Okay, so here we are going to have right. So the B1 is going to be equal to 5, right? So the B1 is going to be equal to 5, right? So 5. And then the B3 can then be calculated, right? So what is a B3? Well, according to this system of equations, you can see that B3 can be calculated in one of these equations. For example, let's take the first one. Okay, so if you take the first one, then you are going to have like B1 is 5 minus 2 times B2 is equal to 4 plus 2 times the B3 is equal to 9. So that's going to tell you that B3 is equal to, this is 1, so 1, then is the 8. So 2B3 is equal to 8, B3 is equal to 4. So that's going to be 4. Is that good for everybody? Okay, so that means you get your vector B, right? So the vector B is equal to 5, 2, and 4. So that's the vector B. Is that good for everybody? Okay, so let's summarize here. Okay, so the B. Okay, so let's find, right. So you find A is equal to the vector we don't know, but we have the B, right? So the B vector is 5, 2, and 4. So that's we find the B vector. Now we want to find the A vector, so you just use the first equation. A times A is equal to B. So that means that you're going to have A times A is equal to B, which means that the matrix A, okay, so matrix A is 1 minus 2 and 2, okay, so 1 minus 2 and 2, and then it's minus 2, 1 and 2, and then it is 2, 2 and 1, minus the vector A is A1, A2, and A3 is going to be equal to the vector B, right? So what is that vector B? Well, vector B, 5, 2, and 4. Okay, so 5, 2, and 4. So that means you're going to have the system of equations A1 minus 2 times A2 plus 2 times A3 is equal to 5 minus 2 of A1 plus A2 plus 2 times A3 is equal to 2, right? So it's equal to 2, and then it's 2 times A1 plus 2 times A2 plus the A3 is equal to 4. Is that good, everybody? Okay, so you have this 3 by 3 equations. Now you want to solve, right? So you want to solve for this equation, so that you can see that if you add the first and third equation, you are going to just have 3 times A1 plus 3 times A3 is equal to 9, which means that A1 plus A3 is equal to 3. That's the first equation. Now you want to cancel A2, So you want to kind of multiply by 2 of this equation, second equation. So that's going to tell you that minus 4 times A1 plus 2 times the A2 plus the 4 times the A3 is equal to 4. Now you add these two equations, that's going to give you minus 3 of X1, right? So plus the 6 of A3 is equal to 9. So that means that A1 minus the 2 times A3 is equal to 3. Okay, sorry, so equal to minus 3. So from these two equations, you can see that A1 is being found, right? So A1 is equal to what? Well, here is means that 2 times A1 plus 2 times A3 is equal to 6. So that means you add these two equations, you're going to have 3, okay, so A1 is equal to 1. Is that good, family? Okay, so A3 is then equal to 2. Is that good, family? Right? So you have 1, you have 2, right? So that's going to be that scenario. Now you can find your A2, right? So how do you find A2? Well, A1 is 1, right? A3 is 2. So that means you're going to have 1 minus 2 times A2 plus the 2 times A3 is 4 is equal to 5. So that A2 is nothing but 0. Is that good, family? You have 0. So that means you have find your vector A also. It's 1, 0, and 2. Is that good, family? Okay, so that means this is 1, 0, and 2. Is that good, family? Okay, once you have this, you can see that the particular solution, all right? So the particular solution by the method of undetermined coefficients is going to be given by x of t is equal to like 1, 0, and 2 plus the 5, 2, and 4 multiplied by t. So that's going to be the particular solution. Is a good, family? Okay, so that's going to be the particular solution. So that's kind of very nice here is that this is actually a polynomial, but it is just a polynomial with vector coefficients. If you want to really write a polynomial, it is actually a polynomial vector. So that's like 1 plus 5 times t, 2t, and 2 plus 4 times t. Is that good, family? Okay, so that's going to be a polynomial vector. Okay, so that's going to be polynomial vector. So that's a particular solution. Now we have fully understood this problem. There is a complementary solution. There is a particular solution, right? So let me say the complementary solution, right? So that means we have to kind of combine the complementary solution with the particular solution. So this is the complementary solution. I will need it, right? So let's say I will need this complementary solution. Okay, so that means you can use this complementary solution, right? So complementary solution, and then we are going to have another equation which is going to give us the particular solution that we just find here, right? So we just find this particular solution here. Okay, so that means this is the particular solution, right? So this is the particular solution. Okay, so that means this is the particular solution. Is a good, family? Okay, so you have the complementary and the particular solution. So that means you can combine these two. Okay, so that means if you combine these two, you're going to get a general solution, right? So you get a general solution. The general solution is given by x of t is equal to the complementary solution plus the particular solution. Is a good, family? Okay, so the complementary plus the particular solution, c1 e power minus 3t multiplied by minus 1, minus 1, and 1 plus c2 e power of the 3t multiplied by 1, minus 1, and 0, and plus the c3 multiplied by e power of the 3 multiplied by 1, 0, and 1, and then plus this complementary solution, a particular solution. We can use this vector equation. So that's 1 plus 5 times t, 2 times t, and 2 plus 4 times the t. Is that good, family? Okay, so that's the solution of this undetermined, this non-homogeneous equation. Okay, so non-homogeneous system that we see at the very beginning is a 3x3 matrix, but we use the so-called method of undetermined coefficients to fully find this whole solution, including the complementary and the particular solution, and reach the general solution. Is that good, family? Okay, so that's the method of undetermined coefficients. Okay, so that's the method of undetermined coefficients. Okay, so that might be all I want to say for today's lecture. Let's come back to the next lecture, and we're going to continue with our lectures. Okay, so see you in the next lecture.